We have 5 more lightning round speakers who are going to talk about some amazing opportunities for teens in tech. First, we have Andy and Ashley from the Terra Nova Robotics Team. They compete in a special category of FIRST robotics called the FIRST Tech Challenge. Robots in this category must fit inside an 18-inch square box and accomplish some pretty crazy tasks. So I just want to thank them for taking the time out of preparing for this year's robotics season to come talk with us.
Hi, my name is Andy.
I'm Cho.
And I'm Ashley, and as was said before, we're from Terra Nova Robotics in Pacifica, California, and we're kind of still, oh no, we are okay. So we'd like to tell you about our robot and team.
We compete in an organization called FIRST, which stands for Inspiration and Recognition of Science and Technology. This was founded by Dean Kamen, who also invented the Segway. Within FIRST, there's 4 different levels. There's Junior FIRST LEGO League and FIRST LEGO League for K-8 schools, and there's FIRST Tech Challenge and FIRST Robotics Competition for high schools.
As Andy said, FIRST Tech Challenge, or FTC, is the league we compete in with our robots. And in FTC, 4 teams compete on a 12 by 12 foot field. This is a picture from a few years ago where robots had to pick up rings from the side of the goal, from the side of the field, and score them on a 3 by 3 pegboard in the middle. It's kind of like robotics tic-tac-toe. And at the beginning of every match, there's 30 seconds of autonomous where a robot has to find an infrared beacon using an infrared sensor and score, and it's all pre-programmed. We're not controlling the robot at all. And normally, all 4 robots would be moving at once instead of just the one, but this shows you fairly well what they can do.
After the autonomous period, there's 2 minutes of a teleop period, or driver control period. In this period, drivers drive the robots in order to pick up scoring elements, and they can either score the elements or block other robots from scoring. In our league, there's restrictions to what you can build out of. There's restrictions to the type and number of motors you can use, but we can use any raw materials and we can machine them to anything we want.
The programming language we use is called Robot C. It's a variant of the C language with functions for robots.
We also use CAD, or computer-aided design, to help us design our robot within the computer before physically building it up, and that saves us both time and money. And we can also use it to show specific mechanisms of the robot that would otherwise be hidden.
So this is a CAD buildup of this robot right here. This robot has 3 main ideas. There's a throw drive for mobility, a block conveyor to pick up scoring elements, and a lift to hang the robot at the end of a match. And as Mark says, our league has an 18-inch size restriction, so our lift and block conveyor fold into itself.
And now we're going to transition into our Prezi portion of our presentation.
So before we start the design process, we do a prep step. So first we build the field, then we understand the game rules, because if we misunderstand it, then we can build the wrong robot. Next we understand the allowed materials. Then we drive last year's robots on this year's field just to get a sense of all the obstacles on the new field.
So after all of our prep work, we actually start designing our robot. And the first thing we always do is strategize, because we have to strategize what we want our robot to do. And we always strategize and brainstorm using a whiteboard, because it helps share our ideas with our team members so much easier than trying to explain it. After that, we research. So we research past year game challenges that have similarities to this year's. And we also research real-world mechanisms that have applications towards our robot. Then we have to identify our subassemblies. And a subassembly is just a bunch of parts thrown together to accomplish a goal. So like an arm or a lift. Then we have our space assignments, because if you stack subassemblies one on top of another, you'll have something like this where you can't access the things in the middle. But if you plan it out beforehand, you'll have something like this, where you can access it from the exterior and interior. And this is one of our space assignments from a few years ago. After our space assignments, we have an order of integration, which is pretty much just what order the sub-assemblies are that we're going to build. And that's when we start developing the sub-assemblies themselves. And our development of sub-assemblies is a looped process, where we only start on a new subassembly after we completely finish the last one. And the first step is always listing the requirements and constraints. Then we always brainstorm our ideas on a whiteboard, like I said before. Then we have to prove the concept that we brainstormed before, like in here. We needed to know if two chains could bring a ball up, like that. After we're done with our proof of concept, we have to identify the subassembly interactions, because the two gears shown were almost in conflict with the sprocket, so we have to make sure nothing's ever in conflict with each other. Then we have to mock up our thing to make sure it's working, which we then test, and then we optimize it, which means we make it smaller, faster, stronger. And one thing our team always does is make an FEA, or a finite element analysis, which shows the forces put on a piece, and we can take out weight that we wouldn't otherwise know about. Then we plan out and mark our pieces, which leads us to cutting and machining them, which we then assemble and test if applicable. And if everything worked out right, we move on to our next subassembly.
And along with using CAD in our design process, we also use CAD for manufacturing our pieces. So we 3D printed the pieces shown here, and 3D printing is an additive process, whereas CNC milling is a subtractive process. And this is a bit of a sped up version of us milling some hubs. And these are the final hubs. And if your team works really hard and you have a lot of luck on your side, you might be able to advance to the World Championships. And the World Championships is really fun, and you can compete with teams from all around the world.
So we're Terra Nova Robotics once again. I don't know if we have time for questions right now, but in 10-20 minutes during the networking break, we'll be outside on the patio letting you guys drive our robots. So if you have any questions then, please come up and ask. And thank you for listening to our presentation.